Hello friends, welcome to Simple Mechatronics. The lithium iron phosphate cells gaining popularity due to its advantages like high capacity to weight ratio, low leakage, high ampere hours capacity, longer lifespan, safe while charging and discharging, suitable for power banks, and so on. 3 cells are packed in series here for charging with positive connection, 2 junctions, and negative connection. Now, here is the project for series balanced lithium iron phosphate cell charger for 3 cells. A general purpose PCB is selected for circuit board. 3 numbers of LM338 voltage regulators with heat sinks are used and planned its position on the PCB. Suitable holes are to be drilled on the PCB for fixing in a cabinet. This is the complete circuit diagram. Press like button if you liked this video and subscribe to encourage us for more projects. So, start soldering the voltage regulator ICs on PCB by providing space for related components of the circuit. The holes of the ICs should match the holes of heat sinks while soldering. Mark the power supply lines on PCB for convenience before soldering the other components. Initially, solder diodes near ICs with correct polarity. Then, resistors, trim pots, output diodes and other components by following the circuit diagram. Solder the capacitors, 2-pin connector, and indicator LED, as shown. For testing purpose, connect about 15 volts DC supply to the circuit board. Now adjust each trim pot connected to each LM338 to get output voltages as 3.8 volts, 7.6 volts, and 11.4 volts. Also check for 12 volts output from 7812 IC. Solder wires for input and output connections. Different colored wires are used for easy identification. Now, the circuit board is ready. Now, fix the heat sinks for LM338 ICs, one by one, using screws. An SMPS container is selected with 12 volts cooling fan. Plan for a power switch and combined digital voltmeter and ammeter on front panel. Required openings are made to hold them. A front panel is designed using a cardboard with opening for ventilation. Fix the front panel, then digital meter, and then the switch. A 5-wire connector is fixed for different voltage outputs. A 12 volts 3 amps transformer is fitted in the container using screws. The input power supply to the transformer is connected through the switch in series. 3 or 4 screws are provided in the container for holding the circuit board. Now, fix the circuit board carefully inside the container, matching to the screw positions. Then, lock it with nuts. Then, initially connect input wires to transformer. Then, push the output wires through cardboard and connect them to output strip connector as shown. Connect mains power supply to the circuit at back side of the container and switch on. The indicator LED on PCB glows. Now, once again test the output voltages. Then, connect the 3-pin connector to digital meter to show voltage. Connect cooling fan connector on PCB. Connect thick wire connector to the digital meter to read current flow. To test current flow reading, a load resistor is connected to each output. Close the container using the screws. Please press like button if you like this video and subscribe for more projects. A battery box is required to hold the 3 LiFePO4 cells properly. A strip connector is used to connect the positive, negative poles and junctions of the 3 cells in series. Different colored wires are used for easy identification of wiring. Check voltages after connections. Fix the battery box over the closed container. Now connect the 4 outputs of the container to 4 inputs of battery box in parallel. Remove the cells, then switch on the power supply and read 11.4 volts on digital meter. When the cells are placed in the battery box, one by one, the charging of cells start. The charging current is displayed on the second row of the meter. As the charging raises, the voltage increases and charging current decreases. On full charging, the meter shows 11.4 volts and 0 amperes. Thanks for watching the video. More explanation and more videos are available at Simple Mechatronics website. Links for other projects are available at description below. Bye friends, see you in the next project.